The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Example, units of force. 1 Newton is equal to, well, we just said the force is equal to 1 Newton, right? And we're shortly going to see that from algebraically from Newton's second law, right, that force is actually going to be equal to mass times acceleration, right? And mass, we know, has units of kilograms, while acceleration has units of meters per second squared. Now, knowing that bit of information, our answer will end up being D. Great. And it's also in the customary United States system, the unit for force is the pound, right? And it's also just good to note that 1 Newton is actually equal to roughly just a little bit more than 1/5 of a pound, as we see here. Okay, great. Let's now move on to our next slide. Now we'll take a look at net force. Net force is the sum of multiple forces acting on an object. Only net force is attributed with causing change in motion. So if we take a look here at our first diagram, right, we see that we have an object here, right, whatever that object is. So this is a free body diagram, which we'll cover in just a moment. We have 3 different forces acting on this object in 3 different directions. Well, the vector sum of all these forces, right, so force 1, force 2, and force 3 is actually going to be force net, right? Thus, that is why we can write force net as such, because now, if we go back to our definition, only net force is attributed with causing change in motion. And that's exactly what we see here. Okay, great. And we'll be doing multiple examples of this in just a moment. Now, before we move on, one other thing that I would like to discuss is, just so we're comfortable with here, a quick review of balanced forces and unbalanced forces, right? So we'll first take a look at balanced forces. This book sitting on the desk has 2 forces acting on it, right? It's going to have the force of gravity downwards, and it's going to have the force from the desk upwards. Now, because these 2 forces are going to be equal in magnitude, right? We know that these 2 forces that we're working here with balanced forces, right? And just to talk a little bit more about balanced forces, let's look at our bullets now. When the forces are balanced, object is said to be at equilibrium. Okay, great. The net force is going to be equal to 0. Again, the 2 forces are going to be equal in magnitude, right? And acceleration is 0 when you're working with balanced forces. Now, let's contrast balanced forces with an unbalanced force. Let's take a look at our book here. Now, if this book, and again, we're going to make the assumption that air resistance is negligible, right? So the only force acting on this book is the force of gravity, right? In that scenario, that is what we would consider to be a unbalanced force. Okay, great. Now we are ready to move on. Next slide. All right, what do we, okay.